One.
So I'm going to talk about discrete variables, which an example could be binomial distribution. A binomial distribution with parameters n and p is the discrete probability distribution of the number of successes in a sequence of n independent yes or no experiments, each of which yields success with probability p. A success or failure experiment is also called a Bernoulli experiment or Bernoulli trial. When n equals 1, the binomial distribution is a Bernoulli distribution. The binomial distribution is the basis for the popular binomial test or statistical significance. The binomial distribution is frequently used to model the numbers of successes in a sample of size n drawn with replacement from a population of size n. If the sampling is carried out without replacement, the draws are not independent and the resulting distribution is a hypergeometric distribution, not a binomial one. However, for a much larger than n, the binomial distribution remains a good approximation and widely used. So this is a function and parameters for a binomial distribution. The function goes n combination y times p to the y times q to the n minus y, where c equals combination, y equals number of attempts, n equals sample size, p is the probability of success, and q is the complement of probability. So now we're going to use GeoGebra to show an example. Here we have two graphs, one of the mass function, which is the escalated one, like it looks like the stairs, and the general probability function graph, which is the bars one. So we're going to see how it behaves. When the number of attempts n increases, both graphs tend to go to the right and to extend at the same time. And if it decreases, both tend to compact and go to the left. Now, if the probability increases, both graphs tend to go to the right without extending themselves. And if the probability decreases, they tend to go to the left. So we see that it's very simple. If attempts or probability increases, graphs go to the right, and if it decreases, they go to the left. Same with probability. If the probability increases, they go to the right, and if it decreases, they go to the left. So that's basically the behavior of a binomial distribution function graph.
The Poisson distribution is a discrete probability function that sets a frequency occurrence average and describes the number of times an event occurs in a finite space observation. For example, a Poisson distribution can describe the number of defects in the mechanical system of an aircraft, or the number of calls to a center of calls. This distribution is often used in quality control, survival studies, and insurance. An event can occur 0 to n times in an interval. The average number of events in an interval is designated by lambda. Lambda is the event rate, also called the rate parameter. This probability function is given by this equation, where lambda is the average number of events per interval. E is the number of Euler's number, and k takes the value from 0 to n. A variable follows a Poisson distribution if the following conditions are satisfied. The data are event counts that are not negative integers with no upper limit. All events are independent, and the average rate does not change during the period of interest. The Poisson distribution is defined by the parameter lambda. This parameter is equal to the mean and the variance. As lambda increases, the Poisson distribution approaches a normal distribution.
The exponential function is a continuous variable that describes the time in which an event occurs, knowing that the event can occur in every instant until the event happens. The formula of the exponential distribution is 1 minus e exponential minus y slash beta. Also, we know that the mean is beta and the variance of the function is beta to the square. This distribution has many uses. One of these is that it's ligated to the Poisson. Also, we know that with this measure you can know the time that a truck is charged, or the time you spend playing video games, or the time between entry and exit of person in a public room. This function have a lot of uses. In the graphic that it's now put, we can see that no matter if we change the alpha number, the function is always be growing exponentially until it reaches the one that it's the mean.